Another day, another story. The language and image recognition capabilities of AI systems have developed very rapidly. The chart shows how we got here by zooming into the last 2 decades of AI development. The plotted data stems from a number of tests in which human and AI performance were evaluated in different domains, from handwriting recognition to language understanding. Welcome to Tableau Eminent Channel. Within each of the domains, the initial performance of the AI system is set to -100, and human performance in these tests is used as a baseline set to 0. This means that when the model's performance crosses the 0 line is when the AI system scored more points in the relevant test than the humans who did the same test. Just 10 years ago, no machine could reliably provide language or image recognition at a human level. But, as the chart shows, AI systems have become steadily more capable and are now beating humans in tests in all these domains. Outside of these standardized tests, the performance of these AIs is mixed. In some real-world cases, these systems are still performing much worse than humans. On the other hand, some implementations of such AI systems are already so cheap that they are available on the phone in your pocket. Image recognition categorizes your photos and speech recognition transcribes what you dictate. Language recognition and production is developing fast. Just as striking as the advances of image-generating AIs is the rapid development of systems that parse and respond to human language. The image shows examples of an AI system developed by Google called Palm. In these 6 examples, the system was asked to explain 6 different jokes. I find the explanation in the bottom right particularly remarkable. The AI explains an anti-joke specifically meant to confuse the listener. AIs that produce language have entered our world in many ways over the last few years. Emails get auto-completed, massive amounts of online texts get translated, videos get automatically transcribed, school children use language models to do their homework, reports get auto-generated, and media outlets publish AI-generated journalism. AI systems are not yet able to produce long, coherent texts. In the future, we will see whether the recent developments will slow down, or even end, or whether we will one day read a best-selling novel written by an AI. Where we are now, AI is here. These rapid advances in AI capabilities have made it possible to use machines in a wide range of new domains. When you book a flight, it is often an artificial intelligence, no longer a human, that decides what you pay. When you get to the airport, it is an AI system that monitors what you do at the airport. And once you are on the plane, an AI system assists the pilot in flying you to your destination. AI systems also increasingly determine whether you get a loan, are eligible for welfare, or get hired for a particular job. Increasingly, they help determine who is released from jail. Several governments have purchased autonomous weapons systems for warfare, and some use AI systems for surveillance and oppression. AI systems help to program the software you use and translate the texts you read. Virtual assistants, operated by speech recognition, have entered many households over the last decade. Now self-driving cars are becoming a reality. In the last few years, AI systems have helped to make progress on some of the hardest problems in science. Large AIs called recommender systems determine what you see on social media, which products are shown to you in online shops, and what gets recommended to you on YouTube. Increasingly, they are not just recommending the media we consume, but based on their capacity to generate images and texts, they are also creating the media we consume. Artificial intelligence is no longer a technology of the future. AI is here, and much of what is reality now would have looked like sci-fi just recently. It is a technology that already impacts all of us, and the list above includes just a few of its many applications. The wide range of listed applications makes clear that this is a very general technology that can be used by people for some extremely good goals, and some extraordinarily bad ones, too. For such dual-use technologies, it is important that all of us develop an understanding of what is happening and how we want the technology to be used. Just 2 decades ago, the world was very different. What might AI technology be capable of in the future? What is next? The AI systems that we just considered are the result of decades of steady advances in AI technology. The big chart below brings this history over the last 8 decades into perspective. It is based on the dataset produced by Jamie Sevilla and colleagues. The rise of artificial intelligence over the last 8 decades. As training computation has increased, AI systems have become more powerful. Each small circle in this chart represents one AI system. The circle's position on the horizontal axis indicates when the AI system was built, and its position on the vertical axis shows the amount of computation used to train the particular AI system. Training computation is measured in floating point operations, or FLOP for short. One FLOP is equivalent to one addition, subtraction, multiplication, or division of two decimal numbers. All AI systems that rely on machine learning need to be trained, and in these systems, training computation is one of the 3 fundamental factors that are driving the capabilities of the system. The other 2 factors are the algorithms and the input data used for the training. The visualization shows that as training computation has increased, AI systems have become more and more powerful. The timeline goes back to the 1940s when electronic computers were first invented. The first shown AI system is Theseus, Claude Shannon's robotic mouse from 1950 that I mentioned at the beginning. Towards the other end of the timeline, you find AI systems like DALL-E and Palm. We just discussed their abilities to produce photorealistic images and interpret and generate language. They are among the AI systems that used the largest amount of training computation to date. The training computation is plotted on a logarithmic scale so that from each grid line to the next, it shows a 100-fold increase. This long-run perspective shows a continuous increase. For the first 6 decades, training computation increased in line with Moore's law, doubling roughly every 20 months. Since about 2010, this exponential growth has sped up further, to a doubling time of just about 6 months. That is an astonishingly fast rate of growth. The fast doubling times have accrued to large increases. Palm's training computation was 2.5 billion petaflop, more than 5 million times larger than AlexNet, the AI with the largest training computation just 10 years earlier. Scale-up was already exponential and has sped up substantially over the past decade. What can we learn from this historical development for the future of AI? Studying the long-run trends to predict the future of AI. Researchers study these long-term trends to see what is possible in the future. 11. Perhaps the most widely discussed study of this kind was published by AI researcher Ajaya Kotra. She studied the increase in training computation to ask at what point the computation to train an AI system could match that of the human brain. The idea is that, at this point, the AI system would match the capabilities of a human brain. In her latest update, Kotra estimated a 50% probability that such transformative AI will be developed by the year 2040, less than 2 decades from now. Thanks for watching. Request you to subscribe the channel.